Good morning everyone. I am D. Bimal Rahul, roll number AV.SC.U4AIE23108 from the Mobile Application Development course. Today I will be presenting on the topic resource files in Android. This topic is an important foundation for Android developers because resources helps us design user interface, manage app data and support multiple device types all in an efficient and organized way. So let's begin exploring how Android uses source files to make applications flexible and powerful. Android resource files include a wide range of non-code assets like images, XML layouts, strings, colors, and menus that together support the functionality and user interface of Android applications. These files are stored separately from the source code, which promotes cleaner code, better maintainability, and modularity. Developers can easily update or modify app content, such as changing an image or text, without altering the program logic. Source files also allow apps to adapt to various device screen sizes and languages by providing alternative assets for each configuration. The separation of resources from logic improves scalability and simplifies maintenance, which is essential for large long-term Android projects. This slide focuses on how large resource files maximize adaptability, maintainability, and collaboration. In Android app development, resource files allow developers to adapt applications to different devices and configurations by providing multiple versions of same asset, such as separate images for different screen densities. They also enable internalization and localization by keeping all text content in files like strings.xml, making it easy to provide translations for different languages. Through centralized style and color files, resource files ensure UI consistency and better theme control. By isolating resources from code, developers can safely update or modify assets without affecting the app's logic. Finally, this approach improves teamwork, allowing designers to work on UI and visual components independently, while developers focus on the functionality. The resource folder in Android projects is the main container for all resources files. It is carefully structured to organize and access resources efficiently. The drawable folder contains all images and graphic resources, including PNG, JPEG, and vector files. The layout folder holds XML files that define the user interface layout for different screens and components. The values folder stores XML files such as strings, colors, dimensions, and style definitions that are reused throughout the app. The menu folder includes XML files that define app menus and toolbar items for navigation. The bitmap folder stores launcher icons optimized for multiple screen densities to ensure sharpness. Finally, the raw folder stores unprocessed asset files like audio, video, or custom data used directly by the app. The structure helps maintain an organized, scalable Android project where every resource has a clear purpose and location. This slide highlights the key types of resource files used in Android development. Drawable resources include images, vector graphics, and shape files that define the app's visual elements. Layout resources are XML files that structure the app's user interface components. And values resource contains XML files such as strings, colors, dimensions, and styles for UI customization. Bitmap resources store launcher icons optimized for various screen resolutions, and raw resources hold unprocessed files like audio and video that the app can access directly. And menu resources define the app's navigation menus and toolbar items. Understanding these resources files types allows developers to organize and optimize app assets effectively, resulting in cleaner design and improved performance. Drawable resources are crucial for creating visually appealing and scalable Android user interface. These are the three main types of drawables: bitmap images such as PNG or JPEG, ideal for detailed icons or photos that require rich color with the vector drawables, which are XML-based scalable graphics that automatically adjust to any screen size while keeping the app size smaller, and shape drawables, which define simple UI components like buttons or backgrounds through XML shapes, gradients, and corners. And using vector drawables ensure crisp, consistent graphics across all devices and screen densities, reducing the need for multiple image versions and improving app performance and consistency. Layout XML files define how the app's user interface is structured. These files located in the layout folder describe the hierarchical arrangement of UI components such as text views, buttons, and recycle views. For example, a simple linear layout may arrange elements vertically or horizontally with attributes that define size, padding, and alignment. By separating layout design from code logic, developers can easily make visual change or adjust the UI without altering the underlying functionality. The structure also supports teamwork. Designers can focus on layout files while developers handle functionality, improving workflow and consistency. The values folder plays a key role in making Android apps scalable and easily maintainable. Fields like diamonds.xml, colors.xml, and styles.xml define standard UI constants such as margins, font sizes, color themes. For example, diamonds.xml allows developers to define dimensions once and reuse them across the app, ensuring uniform design and spacing on all screens. Centralizing these values improves maintainability and enables dynamic UI adjustments without modifying source code. This approach leads to a consistent user experience and supports multiple device configurations efficiently. Menu resources are XML files that define the navigation items, icons, and actions in an Android app. These files are stored in the menu folder and specify each menu item's ID, icon title, and action behavior. For instance, simple menu might contain a settings item with an icon and title that appears when there's enough space on the toolbar. Menus can be modified or extended easily by editing these XML files without changing the Kotlin or Java code. This design pattern improves app navigation and keeps the UI flexible and consistent across screens. This slide explains the purpose of the raw and minimap folders. The raw folder stores unprocessed files like audio, video, or binary data that the app uses directly. Developers can access these resources via resource IDs for media playback or custom data processing. The bitmap folder, on the other hand, stores launcher icons optimized for multiple screen densities, ensuring that the app's logo appears sharp and professional on all devices. Bitmap prioritizes icon quality and loading performance, enhancing the brand's visual presentation and user experience across Android devices. Resource qualifiers and localized make Android apps adaptive and globally accessible. Resource qualifiers allow developers to create multiple resource versions for different device configurations, such as screen size, orientation, or density. For example, using folders like layout, land for landscape, or drawable HDPA for high density images. Localization, on the other hand, enables internationalization by maintaining separate string resource files for each language, such as value N for English or value C for Hindi. Android automatically selects the correct file based on the user's device settings, ensuring that users around the world can use the app preferred language without additional coding. Android resource files are essential for creating modular, adaptable, and user-friendly applications. They separate UI and design assets for logic, supporting easier updates and testing. They enhance adaptability by allowing the same app to run smoothly on different devices, screen sizes, and configurations. They enable effortless localization by maintaining separate string files for multiple languages. They promote collaboration between designers and developers, allowing both to work independently. And finally, they encourage reusability as common elements like colors, fonts, and styles can be shared throughout the app. Together, these advantages leads to efficient, maintainable, and scalable Android applications that deliver an excellent user experience. Now let us move on to the practical demonstration part of the presentation where I will explain the how resource files are used in Android Studio. So first as we can see the Android Studio is open and the project is loaded. Inside the project on the left hand side we can see the app folder. When we expand the app folder we can see another folder name and address stand for resources. So under the rest folder we can see several subfolders like drawable, layout values and image map. The drawable folder is where all the images and graphical resources are stored. The layout folder contains XML files that define the user interface. The value folder holds XML files like strings, colors, and themes. So now in this video, the drawable folder adds an image named forest.jpg. This image will later be used as a background for our main layout. Adding images like this helps us design the UI visually using drawable resources. Next, we open the activity main XML file inside the layout folder. This file defines the structure and components of our main screen. By default, Android creates layout using the constraint layout. This demonstration, we remove the constraint layout and replace it with linear layout, which is simpler and easier to manage for a basic UI design. After replacing the layout, we modify it to include background images and center the content. So in this XML code, we add Android background at the right drawable forest. So Android gravity center. This means that the background of the app screen will not display the forest image that we added earlier, and all the text or components inside the layout will be centered properly on the screen. Then we go to the values folder and open the themes.xml file. In this file, we define the primary color of our app. Then we change the color setting to yellow so that it becomes visible on top of our dark forest background. After that, we quickly open strings.xml file. This file stores all the text used in the app, which has the label. For this demonstration, we don't make any changes here. Just observe how the strings resources are defined can be accessed from anywhere in the project. Next, back to the main activity code where we define the behavior of the app. Here we set the text color of our level string to yellow using. So finally, when the project is run on the emulator, you can see the output screen. The background of the app now displays the forest image. The level text appears in the bright yellow color, okay, centered on the screen. Simple demonstration clearly shows how different resources, drawable images, layouts, clusterings are together in Android Studio. It also highlights the importance of keeping visual design elements separate from code logic, which makes the app easier to customize, update, and maintain. Just a few changes in resource files completely modified the appearance of the app. This concludes the practical demonstration of resource file usage in Android Studio. To conclude, we have seen that resource files form the backbone of Android app development. They separate the app's design elements from its logic, which makes development cleaner, faster, and far easier to maintain. Throughout this presentation, we learned about different resource types, including drawable layouts, values, menus, raw files, and min tabs, and how each one contributes to the app's overall look, feel, and functionality. In real-world applications, these concepts are used in every professional Android project. For example, apps like WhatsApp, Instagram, or Google Maps rely heavily on resource files for layouts, localization, and adaptive designs that automatically fit all devices and languages. As the Android ecosystem continues to evolve, efficient resource management will become even more important, especially with foldable devices, where technology and new screen formats. The future scope of resource handling lies in dynamic weaving, AI-assisted UI design, and cloud-based resource delivery, where app visuals can update in real time without requiring new installations. To sum up, mastering resource files not only improves the performance and adaptability of an app, but also helps developers create polished global and future-ready Android experiences. Thank you for your attention.